There is a lake in the middle of Florida so wide that standing on its shore, you cannot see the other side. It just stretches out flat and pale until it meets the sky. On a calm morning it looks like the most peaceful place in the state. Fishermen drift across it before sunrise, wading birds pick through the shallows, and more than 8 million people, roughly a third of Florida's entire population, depend on it for their drinking water without ever thinking twice about where that water actually comes from. In December of 2024, the agencies that manage this lake did something they have done many times before. They opened the gates and let some water out, lowering the surface by a few feet to relieve pressure on an aging wall. Within days, the rivers on both coasts of the state had turned the color of strong coffee, and environmental groups were sounding alarms that had been building for years. This isn't a story about a monster hiding in the water. It's something stranger and, in its own way, more unsettling. A story about what happens when you spend a century trying to control a living system and end up building a container for something you can never fully take back out. Start with the size of the place, because almost nothing about Lake Okeechobee behaves the way you'd expect from a lake its size. It covers roughly 730 square miles, making it the second largest freshwater lake located entirely within the continental United States, trailing only Lake Michigan among lakes that don't cross state or national lines. The native peoples who lived along its shores gave it a name that, in Hichidi, essentially translates to big water, and it's hard to argue with the bluntness of that description. But here's the detail almost nobody appreciates until they hear it. For all that surface area, the lake averages only about 9 feet deep. Picture a sheet of water roughly the size of a small county, spread across the flattest part of Florida, with barely enough depth in most places to keep a tall man's head above the surface. That shape, wide and shallow, is the single most important fact in understanding everything that has happened to this lake over the last century, because a shallow lake behaves completely differently than a deep one when it comes to storing and eventually releasing whatever settles onto its floor. To understand why the lake is managed the way it is today, you have to go back nearly 100 years, to a storm that still ranks among the deadliest natural disasters in American history. In September of 1928, a powerful hurricane moved up out of the Caribbean and crossed directly over the lake. At the time, the only barrier holding the water back was a low earthen bank, built for routine seasonal rises, not for a major storm. Thousands of migrant farm workers lived in small settlements along the lake's southern and eastern shores, drawn there by the rich soil at the water's edge. When the hurricane's winds reversed direction as the eye passed, they drove the entire lake against that low wall, and the wall failed catastrophically. Floodwater surged across the farmland in the middle of the night with almost no warning. Officially, at least 2,500 people died, though many historians believe the real toll was well over 3,000, and the true number will likely never be known, because most victims were black migrant laborers whose deaths were never carefully recorded by the standards of the era. Bodies were recovered from fields, canals, and trees for weeks afterward, and many were buried in unmarked mass graves. It remains one of the deadliest storms in United States history, and it fundamentally changed how the country would treat this lake from that point forward. In direct response to that disaster, the Army Corps of Engineers built what's now called the Herbert Hoover Dyke, a massive earthen levee that eventually encircled the entire lake, stretching around 140 miles. Named after the president who toured the wreckage and championed its construction, the dike was completed in stages over several decades and effectively sealed the lake off from its natural rhythm. Before the wall existed, Okeechobee behaved like a living, breathing system. When it rose during the wet season, it spilled gently over its southern rim and spread out into a slow-moving sheet of water that crept across the landscape, feeding what we now know as the Everglades. That sheet flow wasn't a separate ecosystem sitting next to the lake, it was the lake, extending itself south toward the coast over the course of thousands of years. Once the dike closed that southern edge completely, the lake could no longer overflow the way it always had. From that point on, water could only leave through gates and canals controlled entirely by engineers, which meant the historic flow of water south into the Everglades effectively stopped. That change opened the door to something nobody fully anticipated. With the land south of the lake now safe from seasonal flooding, farmers and developers looked at the exposed soil, a deep, dark layer of decomposed organic material built up over thousands of years of natural flooding, and recognized some of the most fertile farmland in the country. That area became known as the Everglades Agricultural Area, and it was drained, ditched, and planted at a massive scale, with sugarcane eventually becoming its dominant crop. Today, if you fly into South Florida and look down at the neat green grid stretching south from the lake, you're looking at land that used to be part of the Everglades' natural flow path, now given over almost entirely to agriculture. That industry grew into one of the most economically and politically influential forces in the state, with a level of influence over water policy that still shapes decisions about the lake to this day. Large-scale agriculture on that kind of land requires heavy fertilizer use, and fertilizer means phosphorus, a nutrient that makes crops grow fast but that plants only absorb a portion of. The rest washes off with the rain into the drainage canals built to keep the farmland dry. Under the lake's original natural flow, that runoff would have moved slowly south, filtering gradually through 50 miles of marsh before ever reaching open water. But with the dike in place and the southern flow cut off, much of that phosphorus-laden runoff gets pumped in the opposite direction, back north into the lake itself, because the lake had effectively become the region's default holding basin. For decades, that nutrient-heavy water has flowed into Okeechobee with nowhere else to go, and because the lake no longer flushes south the way it once did, a huge share of that phosphorus has simply settled to the bottom and stayed there. Scientists refer to what has accumulated on the lake floor as legacy phosphorus, and by the 1990s, researchers studying the sediment were already documenting an enormous reservoir of it, estimated in the hundreds of tons, embedded in the soft organic muck that lines the bottom of the lake. As long as that sediment sits undisturbed, most of the phosphorus stays chemically bound up and relatively inert. But the moment enough water movement lifts that sediment off the bottom and stirs it back into the water column, the phosphorus becomes available again, and in a shallow, sunlit, warm lake like Okeechobee, phosphorus is essentially fuel for algae. Give the lake's algae population a sudden surge of it, and blooms can spread rapidly, sometimes turning huge sections of open water into thick mats of blue-green algae capable of producing toxins harmful to both wildlife and people. This is the underlying tension that makes every water-level decision at Lake Okeechobee genuinely difficult. Because the lake can no longer spill south, water managers only have two real outlets when the level climbs too high: east through the St. Lucie River into the Indian River Lagoon, one of the most biologically diverse estuaries in North America, or west through the Caloosahatchee River into the Gulf, an area already prone to seasonal red tide outbreaks. There is no third option that avoids sending nutrient-heavy lake water into a sensitive coastal ecosystem. And every time the lake's level pushes close to the upper safety limits of the aging dike, managers are forced to choose which coastline absorbs the impact, because leaving the water in the lake risks compromising a levee that, despite a major reinforcement project finished in 2023, is still considered one of the more vulnerable pieces of infrastructure of its kind in the country. That's exactly the choice federal and state water managers faced heading into December of 2024. The lake had been running high after a wet season, and by the book, that meant lowering it to protect both the dike and the underwater grass beds that fish and wildlife depend on in the shallows. Following the newly adopted Lake Okeechobee System Operating Manual, a set of guidelines finalized just months earlier after years of public input specifically designed to reduce exactly this kind of harmful discharge, the Army Corps of Engineers opened both spillways on December 7, releasing more than 1 billion gallons of water a day down each river, continuing for weeks. Almost immediately, residents and environmental groups on both coasts reported the same thing. Water that had been clear or turquoise turning dark, almost the color of coffee, as the nutrient-heavy lake water displaced the cleaner water in the estuaries. Environmental groups like Captains for Clean Water and Vote Water raised public alarms almost immediately, warning that discharges at this scale could intensify the red tide already lingering on the Gulf Coast and further damage seagrass beds critical to local fisheries. What makes this particular decision so revealing is that it wasn't reckless. It was, by every available account, the outcome of careful, rules-based management, following a plan that had specifically been designed with years of public input to avoid exactly the kind of ecological damage that similar large-scale discharges caused back in 2016 and 2018. And that's the uncomfortable truth sitting underneath this entire story. Even careful, well-intentioned, rules-following water management can still send legacy pollution rushing toward two different coastlines, because the underlying problem was never really about any single decision. It's baked into the structure of the system itself. You cannot lower a shallow lake that has spent a century accumulating decades of nutrient runoff on its floor without some risk of stirring at least part of that sediment back into motion. And once it's in motion, gravity and river current do the rest of the work. The frustrating part, and the part that environmental scientists have been saying publicly for years, is that there is no quick fix sitting on the shelf. You cannot practically dredge legacy phosphorus out of the bottom of a 700-square-mile lake. The sediment itself has become, in the words of researchers who study it, essentially a permanent feature of the lake's chemistry, something to be managed rather than removed. The only real long-term fix on the table is structural, restoring more of the lake's natural ability to move water south again, the way it did before the dike sealed that route off entirely. That's the goal behind a massive, multi-billion-dollar Everglades restoration effort that includes a reservoir project south of the lake specifically designed to hold and treat water before it can reach the sensitive natural areas further south. That project has been underway for years, but it remains significantly behind its original schedule, and pieces of it won't be fully operational for years to come. In the meantime, the same basic choice keeps repeating itself. When the lake rises, managers still only have two doors to send the water through, and both of them lead to a coastline that has to absorb whatever comes out of the lake's floor along with it. It's worth being clear about what this story is and isn't. It isn't evidence of some unknown, sinister force lurking beneath the surface, waiting to be unleashed. It's a documented, well-understood consequence of a century-old engineering decision that solved one deadly problem, catastrophic flooding, while quietly creating a much slower, much less visible one. A lake that no longer has a natural way to cleanse itself of the fertilizer runoff it has been absorbing for generations. The dike that protects millions of people from a repeat of 1928 is also the same structure that turned Okeechobee into a holding tank with nowhere for its accumulated pollution to go except back out into the rivers on either side, whenever the water gets high enough to force the issue. And Okeechobee isn't unique in this. The same basic pattern, a shallow water body downstream of heavily fertilized farmland, quietly storing decades of nutrients in its sediment, shows up across the country. It's part of what drives the seasonal dead zone that forms every summer where the Mississippi River empties into the Gulf, carrying decades of agricultural runoff from the entire middle of the country. Similar legacy nutrient problems have been documented in sections of the Chesapeake Bay and around parts of the Great Lakes. Okeechobee is simply one of the more visible, well-studied examples, in part because its size and shallow depth make the effects of any water level change easy to observe from the surrounding rivers within days, sometimes even from satellite imagery that scientists and agencies routinely use to track algae blooms and turbidity along Florida's coast. It's worth understanding just how much precedent there already was for concern by the time December 2024 arrived. In 2016, a similarly large release from the lake triggered a toxic blue-green algae outbreak so severe that Florida's governor declared a state of emergency across 4 counties, with thick, guacamole-colored algae mats coating parts of the St. Lucie estuary and prompting health warnings that kept swimmers and boaters out of the water for weeks. A similar crisis hit again in 2018, when discharges combined with a persistent red tide along the Gulf Coast to produce what many Floridians still refer to simply as the Summer of Slime, a stretch of months where dead fish, manatees, and even dolphins washed ashore in numbers large enough to draw national media attention and measurable damage to the state's tourism economy. Those 2 events are part of why the newer operating manual finalized in 2024 was written specifically with language aimed at reducing the frequency and severity of exactly this kind of large-scale discharge. That's also why so many environmental advocates felt blindsided when a major release happened again just months after the new rules were finalized, even though the release itself technically followed the new guidelines. The wildlife impact of these discharges tends to unfold in a fairly predictable sequence once the water starts moving. Submerged grasses like tape grass and pondweed, which manatees rely on heavily during the winter months when they gather in warmer waters near the lake and its connected rivers, can be smothered or uprooted by the sudden change in water clarity and salinity. Oysters and other filter feeders in the estuaries, already sensitive to rapid shifts in salinity, can experience die-offs when a sudden surge of freshwater arrives all at once instead of gradually. On the Gulf side, The added nutrients can act almost like fertilizer for existing red tide blooms, extending their duration and intensity well beyond what they would have reached on their own. None of this happens because anyone wants it to. It happens because the system, as currently built, genuinely does not have a way to lower the lake without pushing that water, and whatever it's carrying, into ecosystems that are already stretched thin from decades of the same cycle repeating itself. The economic stakes tied to all of this are also significant enough that they shape the politics around every decision. Coastal tourism, sport fishing, and real estate values along both the Treasure Coast and the Gulf Coast are directly affected when local water turns dark and algae warnings go up, sometimes for months at a stretch. At the same time, the agricultural interests south of the lake, particularly the sugar industry that occupies much of the old Everglades agricultural area, represent billions of dollars in economic activity and thousands of jobs, and have historically had substantial influence over water policy debates in Tallahassee and Washington. That combination means every proposal to change how the lake is managed, whether it's buying back farmland to expand water storage capacity, accelerating reservoir construction, or tightening restrictions on fertilizer runoff, runs into a genuinely difficult negotiation between competing, legitimate economic interests, none of which are going away on their own. It's part of why a problem this well understood, with a solution this well documented, has still taken decades to move from planning stages into full construction. None of that complexity makes for as tidy a story as a single villain or a single fix, but it's the actual shape of the problem, and understanding it matters more than any dramatic framing could. The lake didn't do anything wrong in December of 2024. It did exactly what a shallow, sediment-laden basin does when water above it gets deliberately moved at scale, following physics and chemistry that scientists have documented for decades. The people managing it didn't do anything reckless either. They followed a plan built specifically to minimize harm, based on the best available science at the time, and the harm still happened, because the underlying structural problem, a dike that cut off the lake's natural outlet 100 years ago, hasn't actually been fixed yet. It's been managed around, carefully and imperfectly, for as long as anyone alive today has been watching. It's about what happens when human engineering solves an urgent, visible danger while creating a slower, quieter one in its place. The dike genuinely did what it was built to do. It has kept the lake from ever again drowning a community the way it did in 1928, and it protects millions of people who now live and farm around its shores. But sealing a natural system off from its own historic flow doesn't just stop the flooding. It stops the flushing, the renewal, the slow natural process that used to carry sediment and nutrients out to sea instead of letting them build up in one place for 100 years. What rose into the rivers in December of 2024 wasn't some unexplainable phenomenon. It was the accumulated cost of a century of decisions, arriving on schedule, exactly the way the science predicted it would. So the lake sits there today, calm from a distance, 9 feet deep on average, holding both a functioning ecosystem and a long-documented pollution problem inside the same shallow basin, with the next wet season and the next necessary release already somewhere on the horizon. There's no dramatic monster waiting under the surface, but there is a genuinely difficult, unresolved engineering and policy problem, one that pits public safety against ecological health every single time the water climbs too high. Restoring more of the lake's natural connection to the Everglades remains the only real long-term answer anyone has proposed, and it's a solution measured in decades and billions of dollars, not a single dramatic fix. Until that work is finished, the choice water managers face during every wet season will stay exactly the same as it was in December of 2024. Decide which coastline absorbs the lake's accumulated history, because right now, there simply isn't a third option.